Hi, I'm Randall Heyman, a mathematics academic. I'm using my YouTube channel to help university educators, teachers, students and parents during the coronavirus outbreak. So if you'd like me to make a video with some mathematical problems or concepts that you're having difficulty to understand for either you or your students, use the comment section below the video. So we're working on rings part 2. We've already done definitions of rings. This is for a school in California. I should just say to that teacher, I deleted the video that you commented on because it had a mathematical error and I redid it. So if you've got any more comments that will help me fine tune what you're trying to do here, just comment on any of the other videos and I'll pick it up from there. Okay, so what I wanted to do here was just do some examples of some rings, just to get it in place what our thoughts are on that. Plus and multiplication. So this is the classic one that if you want to think, when you think rings, this is probably the one to think of. So this is the integers. Here's the set that's involved. And we use normal. By normal, I mean what we learnt in primary school. Normal addition and multiplication. And you'll see that that gives you satisfies all the conditions for group. The group is abelian, and then there was those 3 things that we need for rings. Also note, this does actually have a multiplicative identity 1, this number 1. Multiply anything by 1, you get the original number. So that one's got a multiplicative unit. What's another one that we want to do? This one, a plus b times root 2, where a and b are real numbers. And we'll do that with plus and multiplication as well. So here, the set is a little bit different to what you might be used to. So for example, some examples of things that are in the set are 1 minus 5 root 2, 3 on 2 plus 7 on 4 root 2. And of course, we can just get the normal integers 5, say, because 5 is 5 plus 0. So I'll put in plus 0 root 2, so you can get all the integers. Normal multiplication and addition. So that's good. Here's another one, 3z plus multiplication. So here we're multiplying the integers by 3. So this has got -6, -3, 0, 3, 6. That's all fine. The interesting thing here, I suppose, is, normal multiplication and addition as well. The interesting thing here is that there's no multiplicative unit or identity multiplicative unit. In other words, we don't have a 1 here. There's no 1. But that's fine in terms of the way I've defined rings. What else we got? Here's another one. So it'll be the set AB, just 2 things in the set, and addition and multiplication. But this time we actually lay out what addition is. We give you a table, or I give you a table. AB, so A, B, BH, B, BA, and I've taken this one from a book that assures me that it is a ring, but you might like to have a check of that one and check that should be a ring. Interesting because there's no numbers here, of course. And what you'll find with rings and groups, for that matter, is that you can get very unusual sort of things that don't have numbers, for example. So if you see in your travels any interesting rings or groups, by all means, drop me a comment, and maybe I'll do a short video at some point with some interesting rings and groups. But the point is, don't get hung up on, this is the one to think of when you think of rings, think of the integers, but don't get hung up about, well, that's all rings are. They're way, way more than that. Any questions on what I've done today, comment below. And also, if you've got any questions on anything to do with mathematics, comment below and I'll try and help you out.